All right, you just want me to start it up?
So yeah, just I'd like to thank Larry to taking this um, webinar tonight, and thank all of you guys for coming on board. I think we're going to go for questions as you want. Just unmute yourself by pressing the space bar, and Larry will answer as he goes. So yeah, if everybody could mute themselves there now and go for that, then cheers.
All right, I'll just share my screen. All right, can you see that okay? Everybody see that? Or anybody? Okay, I'll assume that you can see it. All right, so what I want to talk about is MLSN guidelines and growth potential, and how I've been envisioning this helping out to establish fertilizer management programs. And I just want to begin by, let's get this in, thanking a few people too. But I guess first, we're gonna look at what nutrients are really needed, how you develop a fertilizer management plan using this type of a strategy. And then we're a little bit about guessing nitrogen inputs that come from organic matter, because that's something I think is playing a role in particular in the low input systems that you guys got going on over there with the fescues. We can spend a little time on leach and remove salts if there's someone here that's interested in it, and how the soil plant nutrient guidelines were developed. I don't know if we'll get to those last two unless somebody's interested, because it might just take a little too long. And I wanted to thank Fenton and Neil for helping out with this thing. Neil gave some of his data from soil testing that's with POA greens and fescue rye fairways, a little bit more familiar to management practices I'm used to, and Fenton's stuff helped out getting my head around some of the lower input work. And then Fred Astrom at FG Consulting is somebody I work with over here, and he does some work in Ireland with Neil and a few guys. And then Micah Wood, who's the real leader in some of this MLSN stuff, and we've been working on this since he was in graduate school. He started talking about reducing potassium inputs early 2000s, and he got my interest way back then, and we've been working together ever since on some of these projects. These are the contact information for me. It's easy to find me. If you just search for Stowell on the web, you'll probably find me. There's other sources of information that you can get from these different locations if you're interested. And then I want to plug Micah Woods' information. He's redoing his webpage, but this bottom one, this www.subscribe page /MLSN is where you can get his normal updates on MLSN work. And he's always trying to refine this work even further. And he really has pushed me into the out of the comfort zone in a lot of the recommendations. And now I'm pretty much very comfortable with this methodology now. So the idea is to keep it simple. The MLSN guidelines are just a baseline number. As long as you keep your soils above that baseline, you're just not expected to see a turf response. It's pretty simple as that. So it's a little less complicated than some of the other ways of looking at soils and trying to sort of optimize soil conditions. We're depending on, or we're counting on the soil microbiome and the plants working together to make things work properly, and they don't need a lot of help other than the basic nutrients to keep things growing right. And we use growth potential as a method to predict what kind of fertilizers or how much fertilizers are needed. We're mainly going to look at the nitrogen, and I'll explain how that works. So this is the guideline. I mean, it's just this simple. If today your soil levels are above these numbers here, you're probably in pretty good shape, and you won't see a response to fertilizer applications. Now we're using MLSN extraction because that extraction system was developed to mimic how plants extract nutrients from soils, how they pull the stuff off the cation exchanges, how they solubilize nutrients that are in the system. So MLSN has been widely used. It's easily accessible. Over here it is anyway. I think you have plenty of labs over there that can run it. It's a standard. It's just been used so much. It's very useful, and it's worked well for us in our systems. We avoid things like saturated pastes just because they're going to be looking at salts in the soil. They're nothing that's on the exchange sites. So once those guidelines were developed, and in short, we developed those guidelines by looking at thousands of samples. We started out with a database of 20,000 samples that we trimmed down to about 3,000 that fit into some of the uh, areas that we wanted to. We didn't want to look at clay soils because we knew those were going to have too much nutrients in them anyway. So we're looking at sandy soils, and that's where we got this MLSN guidelines. The sufficiency levels for available nutrition, those are sort of the high medium guidelines that have been around for years. You can see that we're less than half of those guidelines, so you get a pretty big savings there. The GSS refers to the Global Soil Survey. After we completed the MLSN survey work, we decided to go back and take a look around the world and sample from a variety of locations to see how the guideline numbers would turn out from the Global Soil Survey versus MLSN, and they came out pretty good. We see that the Global Soil Survey is looking at even lower calcium levels, and that's probably because there are so many samples in the PACE turf database, and we're from some arid lands that have higher calcium levels, so we probably bias the data up a little bit. So you probably don't need as high as 331. And the way the MLSN guidelines were developed is that there's 10% of the values of soil values from good performing turf fall below these levels. So there's still buffer in the system. So we know that these MLSN guidelines are safe, and they're not a problem. And this is from Bill Kreuzer, one of his extension publications, G2265. And what he's doing here is showing the standard ways of looking at soil test results, where you have the soil results in this column over here. And this ENR is estimated nitrogen release, which I'll be talking about that from this organic matter. These guesses, various labs have different ways of doing it. But we'll talk about that later. I think that's probably parts per million, but they don't tell you what's there. And that would be over the course of a year usually, because there's no way that there's going to be 63 parts per million nitrogen in the system at that time. So you have these guidelines, which are, they're low or medium or optimum or very high, and it doesn't really tell you how to make a recommendation. So they provide the recommendations. A lot of the soil labs will provide the recommendations on the bottom, and a lot of times over here, you will get these recommendations from fertilizer companies. They'll help the analytical labs come up with guidelines. But if you look at this on the bottom, that's 175 kilograms of nitrogen, 100 kilograms of P2O5, and 250 kilograms of K2O. And if we glance up at the top of these guidelines, we look at phosphorus at 30, potassium at 96, and any of these other guidelines, these are all above MLSN guidelines. So these recommendations here would be beyond what is considered necessary for healthy plant growth. The nitrogen one, I'm not sure if that's off or not, because we have to know a little bit more about the plant, where it's growing, and the environmental conditions. So that's one of the keys that we're trying to zero in on with MLSN, is how do we figure out what the plant needs based on how much nitrogen you're going to apply. So there you go. What the plant needs. We know it needs light, CO2, and water. Light, you guys with the links courses is really great. You don't have any light issues. You do, because you're so far north, but that's the light you get is it. Although you get a lot of, maybe not as intense, but you get very long days. CO2, that's maybe one of the benefits of global warming. We have plenty of CO2. That's not a problem. There's no way you can control that. And water, you have some control over water, but we're assuming that you're going to be able to provide the water. So as long as the light, CO2, and water are there's just the minerals that we're going to focus on for MLSN. And the way that we sort of decide what the requirements are going to be is not just out of the blue. We take the new tissues, that the amount of nutrients removed in the tissues, and this is something that you can customize for your own site. And the way you do that is you pull clippings off the best performing area. It's growing the right speed, it's got the right wear tolerance, it's doing everything right, and then get a few different sets of tissue tests so that you can develop your own nitrogen. This is a percentage that's 4, 2, 0.5%, 0.4%. So you can get these ratios figured out, and this will be the ratios that you're going to put back into the soil. So the idea with MLSN is we're looking at replacement based on tissue extraction. And you can define these yourself. And I've got a spreadsheet in here that I'll show you that you can just download. And you can adjust these numbers to meet your turf type for your location. So the numbers I'm going to show you today are just a general cool season turf grass number, which I think you can probably dial in a little bit more detail based on your own data at your site. So this is just sort of a look at the proportional comparisons. We know that nitrogen is the driver. Turfgrass systems are nitrogen deprived. The more nitrogen you put on, the faster it's going to grow. And the faster it grows, the more K, P, calcium, everything else it pulls out of the system in relation to each other. This is work where Kreuzer was involved in this, and Soldat and Cussau. They're looking at clippings removed. And if you put enough nitrogen on to pull off, this is just an example for the ratios, to pull off 50 kilograms of clippings, you're going to have 2 kilograms of N, 0.22 kilograms of P, 1.1 kilograms of K. So your ratio is roughly 9 to 1 to 5 in this case, and this is bent grass, which that puts you in a 4 to 1 to 2 or 4 to 1 to almost 3 ratio. But you can define these numbers for yourself, or you can adjust them in the spreadsheet to get just what you want. But just knowing that nitrogen and figuring out how much nitrogen you're using, which is in one case easy because you know how much you put on, but the other case, and I'm going to talk about, it's a little bit more complicated. So this was put together by a friend of mine, Dave Smith in Canada. He's another Brookside consultant, to sort of get the rough idea that nitrogen's driving the bus. I don't know where iron didn't get on the bus somehow. I don't know how copper got on the bus. But anyway, the general concept is that nitrogen's going to be driving the whole system. So if you know how much nitrogen your plant's using, you can and you're removing the clippings, you can replace those elements as they're taken out. So primarily, clippings are the main way that nutrients get extracted from the soil. If there's leaching of nutrients, that means too much nutrients were applied, like leaching of phosphorus or something like that, or even if you leach calcium, there's just too much of it on there. So it's not what's held in the system. If you have high soil salts, leaching is going to take those away, and I've got a couple of examples that we can talk about if we get the time on salts. But leaching isn't going to remove the cations from the exchange sites. And this is also why we don't want to look at just saturated paste extracts, because those are just salts in solution. You almost inevitably are going to overestimate fertilizer or nutrient requirements using a saturated paste extract. So this is just an impression of what a soil particle would look like, just stylized. In this one, if you count them up, there's 18 calcium ions, there's 4 magnesium, there's 2 potassium, there's 1 sodium, and that would give you the number of charges, and your cation percentages would be 76% calcium, 70% magnesium, 4% potassium, simple stuff like that. But this, you could not grow grass with only 18 molecules of calcium, but it's got the right percentage. So we know the percentages are okay that we've seen. But if you don't have enough calcium in the soil, if you don't have enough exchange capacity, you won't have enough calcium. And that's why we don't look at percentages, because it doesn't deal with the situation of low cation exchange soils. So we always look at the actual parts per million, the actual mass of the elements that are in the soil, and we don't look at the percentages at all. So base cation saturation ratios are not a component of this, and not a component of my recommendation systems. I started out using base cation saturation ratios for a while, but then I moved away from it. And this is what happens in a low pH soil. That's why plants don't do well in them, because there's just no nutrients available. It's all the exchange sites are occupied by hydrogens, and all the calciums and magnesiums and the other cations are gone. It's also a note that ammonium ions are a cation too, so they attach onto the source. So if we try to take into account, so if we're trying to, the idea is we're going to figure out how much nitrogen we're going to put on, or try to guess how much nitrogen is being used by the plant. So that'll give us the amount of other nutrients that are extracted during the course of the year. So if we take all the potential N sources into account, and it's a bunch of them, so we have organic matter, ammonium, or we have ammonia is coming from urea or ammonium sulfate or from other, formaldehyde, IBDU, or any other sort of fertilizer. Those are going to pump ammonium into the soil. And one of the nice things about ammonia is, like we said, like I mentioned earlier, is that it attaches to the cation exchange site, so it just doesn't wash away in rainfall. But if the soil's working right, nitrification is going to take that ammonia to nitrate very rapidly. So most of the time, that ammonia isn't going to hang around. It'll get metabolized. That ends up in rhizosphere and rhizoplane microbes. So there's a lot of microbial activity going on like crazy. That gets put into organic matter. So you got this cycle going around on the left here where you've got competition with the plant and the microbes and everybody else in the system going like crazy. And if you put nitrate fertilizers in, that still feeds all those guys too. And in the end, you're going to have plant uptake of nitrates and ammonia. So the competition is pretty fierce for nitrogen. And as long as we don't put too much nitrogen on, then we can have a pretty good system of regulation. So this was the comment I made. After talking to Finton, I'm trying to figure out how you can grow fescue at 60 kilograms N per hectare per year. And I think part of the nitrogen and it's like the STURF BMPs for fescue is around 115, 110, something like that, kilograms N per hectare per year. I think some of that is coming from organic matter, and it's going to come from organic matter during the peak of the summer months, the warm time of the year when the microbial activity is highest. So that would explain why most of the nitrogen seems to be best applied in the spring when the microbial activity is not very high. So that all the nitrogen's stored up in the system. It's not going to start releasing yet, so you need to give the plants a little bit of an advantage against all the microbes. But even at 1 part per million 1% organic matter, that can release up to 60 kilograms N per hectare over the course of the season. So it doesn't do it all at once. It's going to take months to get that all out of there, and it's going to be slow. And I'm not confident in these numbers either, because these are off of agricultural systems, and we know that that's way different than what we see in turf grasses. There's a lot more. I think there's probably more air available for microbial activity than there is underneath a turf canopy. But I'll just use that 60 kilograms N per hectare as a talking point as we go through here for where some of the extra N is coming through that doesn't match up with some of the numbers that you're using for your fescues. So to get a grip on how much nutrition is extracted from the soil by the turf, we use this turf growth potential model. It's a simple growing degree day model based on a normal distribution. Nothing fancy about it. It's used to predict cool and warm season turfgrass performance. I first developed it in the late 90s, I think, to help describe the interaction between overseeded, cool season overseeding into warm season grasses. And it seemed to be so effective in matching what was happening on in the environment that we carried out a little bit further, realizing that we could use it to calculate nitrogen, potential nitrogen demand. So we're looking at growth potential greater than 50% is really robust, pretty vigorous growth. So things are going pretty well, above 50%. And these models are going to be dialed in. I know Kreuser's working on a bunch of different models for different turf types, and you'll see these things change. And the nice thing about models is you just change the equation and you get a better read on what's going on. This looks like a complicated equation. It's not as bad as it looks. It's just like e to the square root of those things. Anyway, you put it in a spreadsheet, and I've got a spreadsheet that I mentioned earlier. We're going to hand out to you guys, and it just is a simple way of looking at it. And this is basically what it does. That's temperature on the bottom. Sorry, I didn't have time to convert this into centigrade. And I don't know why the United States is still using imperial systems of measure. It's a mystery. I can't explain it, but we're stuck with it. And I think it handicaps all of our kids in school because they have to learn this crazy thing. Anyway, you see that I represent it usually in percent growth potential on the y-axis, so that at about 68 degrees or 20 degrees centigrade, you get the maximum growth. So if you can't get any more growth out of that turf grass, no matter how much nitrogen, no matter how much sun you put on it, that's the best it's going to do. So when we have just a simple model like this, it gives us a rough idea of how the turf is going to perform in different environments. That's what is really handy about these types of models. And we can also use it to estimate nitrogen use. Now, if you see Micah talking about growth potential, I tended to use percentage more. He uses just growth potential. This is a percent growth potential. So his numbers will go from 0 to 1 instead of 0 to 100. I just like the sound of 100. It just seems nice. So this is Dublin. Gives you a rough idea of how turf is growing, and compared to some other locations, we don't think you can get it up to the maximum potential of that grass. If you had more heat, more light, you would be able to pump more growth out of those plants. So under optimum conditions, you probably do better than this, but under your conditions, there's some restriction in growth due to the location. And this is the spreadsheet. So this is pretty much the bottom line. I'll walk you through this sort of slowly here. Maybe I can let me put a let me write on the screen here a little bit. Okay, so up on the top here, you just push in your temperatures by month, and that will interpret into growth potential down here. So these lines across this line across the top is percent growth potential, and if this were 100%, this value would be 3.5, which would be 100% of the nitrogen that we set for the year. So you can adjust this nitrogen level in the model. You can adjust the temperature, and you can adjust this variance factor. And we're just going to look at these two a little bit, but not much. I recommend sort of keeping it with these standard values right now, and just sort of getting a feel for how this looks. But this will then give you all of your nitrogen levels that you'll need to put on by month, and a total on the right side. So we're talking about 115 kilograms per hectare of nitrogen. That number is used to, and those proportions that we talked about of extraction will give us the estimated amounts of PK, calcium, sulfur, iron. And from that, we can determine what, or the level of parts per million of each one of those elements are extracted. So potassium is going to come out. We're going to need 37 parts per million potassium, 9 parts per million phosphorus. And if we take those numbers, so we're going to use that amount in a year. So that's gives us an annual amount of replacement fertilizer we're going to have to apply. But we want to make sure that we stay above the MLSN guidelines. So we've added the MLSN guidelines onto that number. And this gives you a soil test result that would provide sufficient nutrition for a year and not go below the MLSN guidelines. So that's pretty much how simple it is. This would be a site-specific guideline for a particular location. So you can get the spreadsheet to run this from the Pace Turf website up here at the top of the screen. It's journal, paceturf.org/journal/climate. It'll bring to this page, and the metric units are here that you can access. And then, oh boy. So we're just keeping it simple with these guidelines. And when I was talking with Fenton, he's talking about maybe 60 kilograms per hectare per year. So I dropped this level. So in this case, we're saying that under the best conditions, his fescue is only going to use 2.25 kilograms, 22.5 kilograms nitrogen per hectare. And above that, you're not going to get any more yield out of the grass. So from that value, it turns out that we're only going to be using 74 kilograms, which is more in the range of 60 to 80 that Fenton was talking about. But that will result in actually lower MLSN guidelines because you're not going to be pulling so much out of the soil. So if you use the higher numbers that I was talking about, the 3.5 or 35 kilograms per hectare value, you're going to have a more liberal MLSN guideline than you would with this. But this will allow you to, if you want to try to dial in the numbers a little bit more carefully, you can adjust some of these parameters. Let's just see how that would fit out in some of the other ones. And I wanted to comment this, remember there's this 60 kilograms here. So if we got 74 over there that we're putting in 74 or 60 or 74, you're going to end up possibly exposing the grass to 120 kilograms in per hectare per year because you're putting on 60 and there's 60 coming out of the organic matter. So really the turf is seeing 120 kilograms, and that's the number we need to use to figure out how much of the other nutrients are coming out. That's the one I don't have a really good feel for, but we know there's a contribution of organic matter nitrogen, and I think it's playing a role in the systems. Well, let's take a look at the old head and some of Neil's data. And
before you go on,
yes,
what's the downside then for when you go as low as I am? I'm sort of about 30.
When you go with what?
I'm at about 30 kgs of N per hectare per annum. So
if you did that?
No, that's what I do. So what effect does that have on the rest of the nutrition that I'm not pulling out?
Well, you're putting on, I thought you're putting on like 60, right?
No, personally, I'm putting on 30.
Okay, you're putting on 30, and we're saying that possibly you're going to get 60 out of the organic matter. If you adjusted everything down to 30, then maybe the guideline would be a little bit too low if there was nitrogen coming out of the organic matter. So the only risk of not taking into account the organic matter nitrogen is that the plant's going to grow more and take more nutrition out that you wouldn't account for. So when you're looking at all the other elements, if you don't want to run a deficit on the other elements, then to overestimate slightly on the nitrogen that you think the plant is seeing, not the nitrogen you're putting on, but what you think the plant is seeing, will prevent deficits of some of those other elements. Does that make sense to you?
Yeah, right.
Yeah, okay. Yeah, so it's just a trick of trying to figure out how to account for the nitrogen. And one of the big problems right now, and everybody wants to know how you account for organic nitrogen, how it becomes available, when it becomes available. Does it become available the same way every year or not? And I'm not sure. I mean, this immediately makes you think that, well, why don't we just monitor clipping yield and then replace what we pull off in clippings? And that's probably pretty darn close to the best application. You can manage that clipping yield and estimating your nutrient extraction, and then looking at the MLSN guidelines to make sure that you have enough in the soil ahead of time, and you're in pretty good shape. But I mean, clippings are if you want to know how much nutrient is being removed in clippings, clipping yield is pretty much the way to go. So that's a good way to do it, but I think you need to still look at some soils to make sure you have buffer, a little bit of buffer in the soils. So this is what the curves look like for growth potential at the old head, and the estimated amounts of nitrogen that he'd be using is down here at 138 kilograms per hectare. And Neil says he puts on 120 on the greens and 100 on the his rye fescue fairways. So I think this is probably not a bad guess, because we know there's going to be some nitrogen coming out of organic matter, releasing of the organic matter to the turf. So these numbers on this side, so this plus MLSN number for old head is probably pretty good. As long as you stay above these values, then you're not going to have a deficit. There's one other way you can, this is just showing a difference if we want to look at some of the ways you can change the model. You change the variance and you see this drops us down to 70 kilograms per hectare. And I think I'm not encouraging people to mess around a lot with those numbers. I think these guidelines are fairly good, but I mean, they're like super tight. I mean, we're talking about biological systems. So just as long as you have above those numbers, then you're probably safe without any problem. I was just going to show you, we've used these things to try to get estimates from other locations. Amherst, Massachusetts, they're using 100, it says they're going to use 164 kilograms. Places like San Diego, 366 kilograms. That's about right. These numbers, and I can look at some of the validation for you on some of these locations to give you an idea that we're hitting a mark on these things. And then we end up with all these sort of crazy locations over here, which we have this sort of transitioning thing where, what do you grow in July and August? I mean, nothing grows very well. Or you have places like Manila where it's clear what the turf type is, just like it's clear what the turf type is for Ireland. And then we have this really extreme situation where there's periods of the time where you have competition. This is the type of location that we develop these models under, trying to understand what's happening in those transition periods in the spring and the fall. So now, how do you bring this into practice and make a nutrient recommendation based on your soil test guidelines and the MLSN and growth potential work? It's easy. Micah developed this equation that you look at the amount of material in the soil and the expected amount of nutrient that's going to be removed based on days, months, or years. We've been using years for now, but you'd spread out those applications through the year. And then you subtract the parts per million in the soil report, and that gives you the quantity that you need to use to amend the system. So if we look at old head, we'll keep with the 3 to 5 kilogram per hectare per month as the maximum that the plant would be able to use. That gives us this 138 kilogram per year nitrogen use, which is over what he puts on, but probably not too far off based on what's in the organic matter in the soils. And his are around 1 part per 1%. So this is the guideline on the side over here. And you just use it in a simple way. You look at the soil withdrawal. We're gonna withdraw 17 parts per million of phosphorus and 69 parts per million of potassium. That comes out to be 11 parts per million and 45 parts per million. The MLS guideline is 21 or 37. You add those two together, that gives you 32 and 82 parts per million. That's the guideline number for old head. And that compares pretty favorably to the old SLAN methodology, which is 50 parts per million or 110 parts per million. So we got a lot of savings just using this simple methodology to reduce the applications. Now, if we look at the soil testing results from old head, so we got Melic 3 phosphorus at the top. He's got greens. The G is greens, F is fairways. Greens, we're looking at 46 parts per million in phosphorus. Fairways at 21, so they're a little bit on the low side. Greens are lower than they need to be for potassium, but the fairways aren't. Plenty of calcium, plenty of magnesium, plenty of sulfur. The pH is okay. And I put the sodium down here just on the bottom for reference in case we get to it later. But you can see there's some sometimes during the year with the sea spray that sodium gets way out of whack. We'll see if we can get to that a little bit later. So let's just take the potassium example where the MLSN plus the removal from nitrogen applications result in a deficit. So you just, to get the Q in parts per million, multiplied by 1.5 equals parts per million. So we take the desired level minus the observed level times 1.5, that gives us 10 kilograms per hectare of potassium that we're short. So this is the conversion that everybody knows how to make. So you just 10 kilograms times 1.2, that gives us 12 kilograms of K2O. If we're going to use the 0050, that interprets into 24 kilograms of 0050 per hectare over the course of the year, and probably be provided in sort of the guideline that we were looking at as far as the time of year. Now let me just flip over to the spreadsheet. So this is just showing the spreadsheet. So you adjust the temperatures up here. It'll provide the nitrogen requirements and all the rest of the estimated nitrogen use. Not really a requirement. It's more than you're going to put on, but it's probably what we think the plant's going to use. There's a tab on the bottom. You just click on the bottom here and it'll bring up the soil sheet. Does that show for you?
Yeah, that's up.
Okay. So then you just punch in your soil test results in this sheet and you'll get a deficit. It'll tell you how much K2O, P2O5 you need to apply as fertilizer. And then what I mentioned on the tissue side, here's the tissue table. You just go up to tools and protection, unprotect sheet. There's no password, and then you can edit these based on your tissue optimum tissue testing guidelines. You take tissue tests from the best turf that you can find. It's performing perfectly. There's actually, I like to see two types of tissue tests done. One is the perfect performing turf, and one is problem area turf, because then you can get some distinctions between the two. But you'll fill these numbers out, and that'll dial into the program. And for MLSN guidelines, this is where you can adjust the MLSN guidelines. If you don't feel like these are comfortable for you, you can adjust these up to a higher, or I wouldn't go lower than these, but you can adjust those up if you feel like you need to. And then it will provide you with your recommendations based on your soil test results. Very simple. It's a simple little spreadsheet. You can easily download it from the website. Now that must have made a little bit more sense, I hope.
Yeah, that made more sense, all right.
Okay, is it understandable? Does everybody sort of get the idea? Good time to discuss it if it's confusing. Seems to be okay.
I think we're good there, yeah.
Okay. Okay, this is where I think this is where I left it off. That's where it left it off on the other one. Yeah.
Yeah.
All right. So this was just going into why we started looking at MLSN, and really the things that started impacting this is that we are having like 9% of the courses over here were closing. Fertilizer costs were going up, 60% increase in nitrogen, 100% increase in phosphorus. And we're looking at a soil survey from the Golf Course Superintendents Association, and we're seeing people decreasing their rates of application of NP and K pretty dramatically. We look to see if there is a reduction in that just because of the acreage reduction, because courses were closing, and it wasn't. The bulk of the reductions were due to reduced rates of application. So that was an interesting discovery. And then we also found out that people are not really just reducing the rates; they're also reducing their formulations. So there went from a 4 to 1 to 3 ratio of fertilizers to like a 10 to 1 to 6, which that means they're really just pulling phosphates out of the program, because the regulations have been going up pretty steadily around the country, with the exceptions of areas like the Southwest where there's no regulations. And you can see what happens without regulation. We're pumping on way too much phosphorus and potash. So clearly you can grow turf well with a much higher ratio of N to P and K to P. So there's no problems with those numbers. It looks pretty nice. And to validate the model a little bit, oops, sorry about that. We looked at a few different locations that were able to come up with more guidelines, more refined guidelines. And this is Crozier and Soldat's work looking at trinaxipec, ethyl, and phosphorus. And they were finding out that as little as 7 parts per million phosphorus is all that you needed to supply adequate phosphorus to bentgrass. So that doesn't mean every grass is going to operate the same way in every environment that way, but 7 parts per million is a valid number for a tightly controlled environment. So we think our 21 parts per million is pretty significantly above that. And as we mentioned, there's 10% of the samples in our surveys had below 21 parts per million. This was just looking at 32 golf courses that had participated in a webinar. We're looking at their observed, the amount of N that they put on per year versus the predicted N per year based on their climate and the climate appraisal. And we got a pretty good correlation. There are some guys putting on way more, and these guys that are under, these guys are probably closer to the right amount, and they're putting under because there's probably some release from organic matter. That's my guess at this juncture. So we had some other growth chamber studies looking at ryegrass leaf yield. So they were just looking at temperatures. So we're trying to dial in whether or not our temperature models are right. And this is the type of work that Crozier and his crew are working on with bent grasses and other turf types to try to refine some of these issues. And it just gives their details there. It's not important. This is the type of a leaf area that they yielded at 3 different temperatures. And if we look at growth potential at those 3 temperatures, that's what it predicts. And if we run a regression on that, our percent growth potential versus leaf area is just that's a really tight fit. So the 68 degree maximum temperature for 68 degree for optimum temperature for ryegrass was one of the numbers that we picked. And as far as the distribution fitting, we sort of played around with the variance and standard deviation to get it to fit right. There's also some soil nitrate work that was done at University of Connecticut. This is kind of an interesting, different way of looking at whether or not you're predicting nitrogen use or not. So what they did is they applied nitrogen to the soil, urea at 5, 10, 20, all these different rates. And then they looked at the nitrate in the soil. So the stuff that was left over, the stuff the plant didn't use. So you would see that level go up when there was more nitrogen applied than the plant could use. And in our system, looking at this is at 3.4 or 34 kilograms per hectare of nitrogen is the maximum the grass will use. It's estimating about 15 or 150 kilograms in per hectare. And they came out with their end rate and 15 is right about there. So they started just pick up nitrogen in the soil. So this is above this 15 grams per meter square. They're starting to see more nitrogen than the plant can use. So it could use everything they put on, stayed flat, and then it started going up above around 15 parts per million, where we were talking about the plant utilizing that nitrogen. So the numbers are pretty good. And then we have some just regular field observations, anecdotal stuff that doesn't really prove anything, but it gives you confidence that you're in the right direction. This is a situation where it's A4 bent grass growing in an unthrifty condition for us over here anyway. It's not recovering from damage. And then right next to it, this is POA overseeded Bermuda grass, and there's a lot of seed head, and you see just the tons of POA just right in the collars and surrounds, and there's no POA in the green. And this was a low phosphorus strategy. They didn't want to put any phosphorus on. They wanted to keep the POA out of the green, and it's not a bad strategy. And if you look at the POA under a microscope, you can see that anthocyanin production. So, I mean, the bent grass. So the A4 was struggling. It was not happy at all. So if we took jump into the Wayback Machine with Sherman there and take a look at what was going on. This is when the course opened in 2001. They didn't apply any phosphorus since it opened, and you can see the decline in phosphorus levels in the soil over time. And what we sort of like to toy around with this idea is that if you got more fertilizer applied than the plant can use, you're going to see an accumulation of that nutrient in the soil. And if you put less in, you're going to have a reduction over time. And if you don't keep enough of it in the soil, then you're going to crash. And that's pretty what happened with Talega there. There's also a situation with putting too much in the soil, which I'm not sure we'll have time to get to that one, but that's mainly focusing on nitrogen. And then proper maintenance is that you keep the right amount of nutrients going on, you have level flight, you're not putting too much, so the soil level should stay pretty much the same. So in this case, where it crashed, we came back in and we applied 2 applications of half a pound of monoammonium phosphate, 1152-0, and then looked at the response and looked at the soil test. And of course, it was a nice phosphorus response. And we took replicated samples from the treated. This is a knockout trial, which I'm sure you're all familiar with, but you just put a piece of plywood down when you make your applications, and you can come back and see if your application worked out. And this worked out beautifully. And if we look at their easily extractable phosphorus, and this red line indicates where our MLSN guideline is at 21, you can see that both of the treated and non-treated levels, this is where we put on the map. No map was put here. Parts per million on the y-axis. This is the collar. As we suspected, the collar had an abundance of phosphorus, and I guess I should have explained. They put a starter fertilizer down when they overseed, so we got way too much phosphorus in the collar, and that's why the POA is doing so well and seeding so much. but it looks like our treated, there's a little bit of an increase in the treated. And in this case, we went one step further in conducting the analyses. The pH is 7.5. Melic 3 extraction doesn't necessarily work great at that level, so we ran an Olson. This is a bicarbonate extraction. I always run those on samples, but normally it's not that big a deal. But we can see with Olson phosphorus, we saw the increase in the phosphorus in the treated area. Our guideline, which I didn't show in the MLSN, there's a 6 part per million guideline for MLSN. We're still below the 6 part per million guideline that we have for MLSN, but we know that there's buffer down below there. But somewhere around that 6 part per million guideline is probably pretty good. The 21 part per million guideline with MLSN and the elevated pH might be a little low. I'm not quite sure, because we saw good performance at a little above 21 parts per million, but the high pH will have to watch out. So I would recommend probably doing an Olson or a bicarbonate phosphorus test on your high pH soils, just to be sure your phosphorus doesn't get too low. And when we use, let's look at the model to see how that would help us prevent that type of situation from happening. Is we can see that we're going to be pulling out on the right side here 24 parts per million per year. This pretty much shows us the rate of removal based on the application of nitrogen. So if we look at this one more time coming down, we crashed on this end. So the idea is we're just going to start, when we start getting down below, in this case I'm looking at 50. I mean, we got plenty of room between 50 and 21. It looks like more like 25 there. 50 and it should be 21. You can just start putting maintenance fertilizers on and you're fine. So you keep above that, you keep that 21 part per million going on. All right. Another case where we're looking at whether the numbers are falling in the guidelines or right. We know the guidelines are low, but not too low. We don't want to be too low. Was looking at anthracnose on Poa annua, and the current guideline for out of Rutgers is 50 parts per million. They're basing it on getting a little bit of safety out of this curve. We're down at 37. 37 is fine for growth, but you might need to pump up potassium a little bit. And probably the best way to check is to check tissues in that case, because you're looking at 2% potassium in the tissues are what will keep POA under wraps. But in bentgrass systems, if you have 2% or more, you're going to have snow mold problems in the winter. So everything has a little caveat to it, but they're still pretty close. And you can use MLSN in for some IPM work too, just to try to suppress, make sure you're suppressing certain diseases. Now let me just let me stop for a second here and see if there's any questions at this point. Anybody still awake?
I think we're chugging along nicely. Yeah.
Okay.
I think it's going to be important that you do talk about the sodiums, because of the salt splash that the guys would have on the coast. Yeah.
All right. Let's jump down to that. All right. I'll just show you two examples. What I found out, because we work with a lot of saline sodic soils down here, the only thing I found that really helps in moving sodium out of the soil is water. If you have a very pure irrigation water, or even rainfall, and I guess if you have a clay soil, then you're going to benefit from some gypsum. But under sandy conditions, it's mainly just irrigation water. Now what I'm showing here is Denver Country Club before and after 50 millimeter natural rainfall. I'll look at sodium levels that dropped from 133 parts per million to 79 parts per million. So it's a 45% reduction in sodium, which is pretty good. In general over here, we think it takes 150 millimeters to drop those levels by 50%. So what might not be exciting in what I'm going to tell you now is that it's just, you need water to move sodium, and it's as simple as that. Those are those issues. And now if you're looking at percentages, let's see here. Sodium percentage didn't even change in here. But our concern if you want it for diseases such as rapid blight on Poa annua, you want to have your sodium below 110 parts per million. So that's where we trigger leaching with irrigation, or hopefully some rainfall. But we have not found that application of gypsum or lime to help out in leaching. In fact, you can see. Well, see. Let's see if I got anything here. This is another example. It happened just to have the same amount of rainfall, which I think is just an accident. This sodium reduction was 30% with a 50 millimeter rainfall. But you can see this is 766 parts per million. This is Bermuda grass, ryegrass overseeded Bermuda. No problem for the Bermuda really to tolerate that. But the reduction was pretty significant. In this case, we have he's using calcium chloride because sulfate levels were high. Once you get sulfate levels up this high, we start to have a problem also. But the main thing that you can and look at what this is why we moved to calcium chloride instead of calcium sulfate. Sulfate's is a much larger anion than chloride, and it just doesn't move as well. We got 34% reduction in sulfate, and it wasn't that great. I mean, it wasn't bad, but we got 43% in chlorides, and the chlorides are able to allow us to get the chloride out faster and supply some calcium if we were worried about it. But look at the calcium levels here. We know this calcium is not on the exchange sites. This is calcium floating around in the system. So if you have high calcium in the system, I mean, if you got a couple thousand or 1,500 parts per million or 900 parts per million, and you've got some sodium in there that's around, it's not above, not crazy levels, like maybe 300 or 400 parts per million, then just water is all that you need to get rid of it. And I don't know if we get some arguments about that or not, but we haven't seen a dramatic benefit. And usually what happens when people are comparing products in leaching is that everybody puts on a bunch of water with the product. And it's a lot of times you don't see just water by itself as a comparison for reducing sodium levels. So whenever the levels get up, I mean, if they're up and you don't have a rainfall, if you don't have irrigation on your fairways, there isn't a product that you can put on that is going to enhance reduction of sodium. I don't know if that's going to irritate people or not, but that's pretty much, that's what we've seen.
Certainly, there is one or two of the guys there that would have a lot of experience. Terence, what way did you, or what do you do to reduce the sodiums?
Well, certainly when one of the greens that did get a lot of the spray, it was a soil sand green, so we used the gypsum.
Mm-hmm.
But the green that got it this year is a pure sand green now, the gypsum didn't work on that one.
Yeah, I think it's sometimes the experience, we've tried to get gypsum to work like a lot. And my standard recommendation here in irrigated arid areas was to put 10 pounds per thousand, which is like 500 kilograms per hectare monthly to try to help manage sodium. And we never really saw a benefit. Where we did see a benefit is if all you're depending on is rainfall, and if some sodium is getting accumulated in there, then sort of routine gypsum applications will help that rainwater move in. And that's been a common practice out here in areas where we have runoff from snowmelt. In the whole center part of the state of California, they have very pure irrigation water, and that water will not penetrate the soil because it doesn't have enough salts in it. And in those cases, if there's just a little sodium out there, it will accumulate because the water can't move through the soil. So you have to increase the salinity of the water to at least 300 parts per million. And gypsum is a way to do that. And some cases where we have recycled irrigation water that has low salinity but moderate levels of salt, then you can inject gypsum. So the residual sodium carbonates is one of the key things you look at. If it's, I don't know if you guys, you guys have pretty good irrigation water, or is it pretty bad?
Well, I'm just relying mainly on rainwater.
Okay.
We don't
Yeah.
have an irrigation system as such.
Okay. Yeah. Well, if you have rainwater, a little bit of gypsum is going to help move some of that sodium out of there because it'll help the water move into the surface profile. Yeah. That's rough. Just when you're sort of stuck with what nature delivers.
Yeah, sometimes we get a lot of rain, sometimes we don't. So
Yeah. Yeah. Well, without you need to have at least well, yeah, it'd be nice to get if you had 150 millimeters every once in a while. That would really over the course of the month it'd be good. But I think even 50 millimeters a month will probably be okay.
yeah, well, we're doing well at the minute since the dry spell ended. We're getting rain every week, so the green is improving rapidly.
Yeah. Yeah, it's fantastic. I think there's just no solution better than water. You just can't do it without the water anyway. So
Yeah,
the question is whether you put amendments in it or not. I don't know. I just get the water is the main thing and a lot of it.
Yeah. Thank you.
Well, that's coming up on the end. I don't know if there's any more questions I can answer. I can be happy to visit.
Right, guys, Larry is there if you have any questions of any description.
And with that with the salt, does it matter then what type of nitrogen you would use for fertilizers?
I don't think so. You can, it's always nice to use calcium nitrate if you can get your hands on it, because that'll help you a little bit. If you have a little sodium bumping around, that's a nice one. I don't think you have to worry about the salts coming in the fertilizers. I think that's been a concern. I think the rates that we put on are so low that any fear of building up salts is going to be low. And I think the salt indexes I don't think are playing a role. But I mean, if you know you're going to come into a really dry spell, and if you have some sodium on there at all, then definitely calcium nitrate's the way to go. That'll just give you a little bit of help with the sodium.
Yeah, I've used some of that already. Yeah.
Yeah, it's a good product. It's just a little bit hard to dissolve in cold weather. That's if you spray it. If you're just throwing it out, it's not a problem.
No, it's very good. You have the presentation recorded. It might be advantageous if we can share that with the guys so they can, sort of dilute the numbers that we're talking
Sure.
at their own pace. And
yeah, I'll try to put it up on our website. I mean, on YouTube channel. I'll clean it up and get it up there. All right.
Yeah, it's not always easy to understand the numbers that you were talking about at that particular time. So it would be good to have a few minutes to have a look at the numbers.
Yeah, think about it. Yeah. Yeah, and then you can just download the spreadsheet and just sort of take a look at it there too. It looks more confusing than it actually is. I mean, I think it's pretty simple. I think just even using those Dublin numbers as a guideline for just about everybody there would be fine, because most everybody's going to be putting on less nitrogen than what that recommended. So the bottom line is probably just those Dublin MLSN numbers, which were. Let me see.
Yeah, the only issue that I had was N applications sort of through June, July would sort of interfere with your surface conditions at the end of the day's play, if you like. As in, you would grow too much grass in the day.
Yeah, well, you've got it dialed in. So I think you know how much nitrogen to put on. It's this the thing. These are guidelines that we're trying to predict all those other numbers in there. I think the nitrogen is the tricky one. So if you've got nitrogen dialed in, you don't want to put more nitrogen on. But you also don't want to assume that you're not getting nitrogen from the organic matter. So some of that nitrogen in the summer is going to be coming from organic. That's where I think the organic matter is playing a role in the summer. And I don't think you don't need to target those numbers. You need to target clipping yields for sure as your goal with nitrogen and control of growth. You got your foot on the gas pedal with nitrogen. You don't want to necessarily use these guidelines to guide nitrogen. We know that these nitrogen numbers are higher than what you're going to put on because we know there's contribution from organic matter. So it's really clipping yield is going to drive your nitrogen. We need nitrogen to determine, we're using nitrogen to give us an idea of what we think the plant's going to pull out of the soil.
Yeah.
So we want sort of a relatively liberal nitrogen number so that we don't get too low on what the plant is probably pulling out.
Yeah, since we had the presentation from Bill Krauser, we've started to get our clip yield. So, as I said to you during the week, the 5 kilos of 4600 just killed me this year because they obviously have a foot on the gas pedal, and even the PGR started slowing that down as much as they would like.
Yeah. Yeah, well, I think the ultimate is to monitor yield. I mean, that is the ultimate. If you can work that into your system and get used to it, then that's pretty much your guide. And if you know what your replacement nutrients are based on your clipping composition, then you pretty much got it dialed in. And then checking once or twice a year on the soils just to make sure you don't dip below those guidelines. It's pretty. That's pretty good way to do it.
I suppose one question on clip yield. What should be the amount of clip or the target clip yield per 100 square meters or so?
Yeah, that's what it depends, I guess, on what you're trying to do. But, 10 mils per meter square, I think, is what a lot of people are targeting. Some people are going below that, But when you start to get above 20 or 30, then I think you're really starting to have some problems. And I'm not sure if you're using mils per meter squared or what your unit of measure is on that. Now that would be a good one for Micah to really, he is having a lot of interest in fun working with clipping yield.
I was having a lot of just using the jug and measuring it in milliliters.
Mm-hmm.
Yeah. So.
Yeah. Well, do you have a number that you're targeting?
So the number that I think 100 mil per 100 square meters is about the right target, or maybe a tad over that.
Wow.
During the say at the end of our drought or whatever, I had that down to about maybe 30 mil per 100, yeah. which was actually ideal because it means at the end of the day's play is no different than the start of the day. And yeah. You go out in the morning and you wonder what do you have to cut anyway. So you have it's really dialed in at that. But I think maybe 100 for 100 is about right.
100 per 100. Yeah. Yeah, it's just low. Yeah. Yeah, but that's what it takes. I mean, that's what, we talked about this a little before we got started. I mean, you guys have the best handle on what the requirements are. Freaking.
Yeah, the fescue leaves are quite small anyway, so yeah.
Mm-hmm. Yeah.
Larry.
Yes.
Okay. So with greenkeepers in the US, would they be then doing a significant amount of culture practices when working on the MLSN system? So if I read this right, this could be a system where it promotes the idea of sustainability, which has been pushed around this side of the pond. Would your greenkeepers now be starting to do less verticutting, less dusting, less maintenance work on the greens? Or do they carry on as is, just lower nitrogen inputs, but continue on with the same level of physical inputs?
Yeah, well, it's actually, I don't think MLSN is getting less nitrogen inputs. So what's happening is we're getting less phosphorus. Phosphorus has been the main focus over here. So really, the MLSN guidelines really does not impact their practices yet, as far as whatever they're doing, because nitrogen is not heavily regulated, and the regulatory guidelines are oddly above what MLSN predicts as being about as much as you could use. So there hasn't been a limit. So even though we say it's minimum levels for sustainable nutrition, it's like pretty liberal. It's we put a lot more fertilizers out than we need to. So that, I think the bottom line is there, and you're seeing it in the results where people are, the price of the fertilizers go up. So all of a sudden we're not using as many fertilizers. And that's sort of like, well, wait a minute. Is that an agronomic thing or is that a financial? Why were we putting that on there? And phosphorus, they regulate them down and there still hasn't been impacts. And you see the numbers are so low that Crozier and Soldat are coming out with on phosphorus, So they're really not, there's not, these levels are not conservative. I think they're quite liberal.
Okay. Thank you. And sorry, Larry, another question then, you got me started. That question, so essentially organic matter here has been a bit of a focus for 10 plus years, trying to get the organic matter down to a low enough value, primarily for surface conditioning, firmness and so forth. Do you think we might be missing out on something by ignoring the value that organic matter brings to our root zones that we have helped produce there through growing of root systems and so forth? That should we look at it a bit more closely for its value, or is it just too difficult, as you alluded to earlier, saying it's probably easier to look at clipping yield?
Yeah, well, I think the problem with I think the physics is one of the main problems. Plus, I think the unregulated release of nitrogen during the summer is another one. But I think when you have enough organic matter, then the system's not firm enough. So I think that's probably the biggest challenge. But I also think you're going to get if you get the organic matter up, then it's going to be hard to regulate the growth of the grass just because of the release of nitrogen. So I think there's two factors going on there. I think you can regulate growth by lowering organic matter, but I think I mean under normal condition, I mean plants, the organic matter is ideal to have there, but it's just the crazy stuff we're trying to do with with golf course greens. It's hard to justify getting it up.
Yeah. True. Yeah, I accept that.
Yeah.
Thank you.
Well, there doesn't seem to be any more questions, Larry.
All righty.
So I guess on behalf of the Irish Links Initiative, I'd like to thank you for taking time out of your day to present to us. And I'd say before too long, when we get to dilute the information you've shared with us, we might get back onto you and have some more appropriate questions, maybe.
Yeah, that's fine. Yeah. Very good. All right. Well, thank you all. Yeah, just let me know. You got my contact information, and I'll try to get that up onto our YouTube channel, and I'll send you a link, Fenton, and then we'll go from there.
Yeah, perfect. I'll share that with the guys. So, those again, thank you all, guys, for joining in, and look forward to seeing you all next week.